Here we go. We have a question majority vote. So you have given an array of integers where each element, each number represents a vote to a candidate, and our task is to return the candidates that have the votes greater than one third of the total votes. If no such element exists, we need to return -1. So in this case, if you calculate the numbers whose frequency is greater than n by 3, so in total there are two numbers and the numbers are 5 and 6. So this about the problem description. The problem is very simple if you use set or map, but we have to do it in a constant space, so that makes the problem a little bit interesting. So let's try to build the approach. So this is the test case. Before that, there's a prerequisite. So if there are some numbers in an array, if there are some numbers, how many numbers are there whose frequency is greater than n by 2? Whose frequency is greater than n by 2? Just think for a minute, pause this video and think about it. So here is the answer. In total there are only one number. In total there are only one number whose frequency can be greater than n by 2. So if I talk about this question, we need to calculate the number whose frequency is greater than n by 3. So how many total numbers are there? Pause this video for a second and think about it. Here is the answer. The total numbers whose frequency is greater than n by 2 is 2. In total, we can have only two numbers, only two numbers. So we can utilize this thing. So we know there are only two numbers at max possible. So we can assign a number to A or a candidate 1 with a count. Its count is initially 0. So let me give a default value. The default value is maximum. And we have at max two values. So our second candidate will be B. This is its initial value is maximum, and count or frequency, this is count 2. Count 2 is 0. So this algorithm, this approach is very famous and it is known as Morris voting algorithm. So the original algorithm is to calculate the number whose frequency is greater than n by 2, and we need to calculate the number whose frequency is greater than n by 3. I think the algorithm name is extended Morris voting algorithm. So you can also find the number whose frequency is greater than n by k also. So for that you can utilize a array list. In this case we are sure there are at max two numbers, so we can take two variables a and b and the frequencies c1 and c2. So let's start this loop. So first we have this number that our first value is not assigned to any value, so you can assign its the value 2 to this number and the frequency will be 1. Value is 2, frequency is 1. Then we have this number. Is it equal to this number? No, it is not equal to this number. Is our second candidate default? Yes. So you can assign this value to the second candidate. So value will be 1, counter is 1. Next we have 5. Is it equal to this? No. Means this number votes to some other candidate, not this, neither this. So for that you just need to decrement the frequency by 1. So if you decrement the frequency by 1, our counter 1 will be 0 and counter 2 is also equal to 0. Next we have 5. Is it equal to this? No, but our counter 1 is 0, means our candidate 1 now not pointing to any value. So that's the time. This is the important point. We need to assign the value 5 to candidate 1. So assign candidate 5 to value 1 to candidate value 5 to candidate 1, and frequency will be 1. Next we have 5 candidate. Is it equal to this? Yes, means the number, the index this votes to number 5. So 5 count is point to candidate 1. So you just need to increment the frequency of 5 by 1. After incrementing the frequency, next number is also 5. So just increment the frequency. Frequency is 3 now. Next we have value 6. Is it equal to this? No. Is it equal to this? No, it is not equal to this. But our second candidate frequency is 0. Second candidate frequency is 0. So it means we can assign the current value to the second candidate. So just assign the value to the second candidate and increment the frequency. Next we have 6. Is it equal to this? No. Is it equal to second candidate? Yes. So just increment the frequency. Next we have this 6. So increment the frequency. Next we have this 6. Increment the frequency. Next we have this 6. Increment the frequency. So after you have this, the frequency is not the original frequency, because as you go you might decrement the frequencies. So original frequency of value 5 or candidate 5 is 4, but here we have 3. So on the first iteration, after the first iteration, you just know the values. The values are 5 and 6. So after the first iteration, you need to calculate the original frequencies of candidate 5 and 6. So first in decrement or reinitialize frequency to 0. So as you see value equal to candidate 1 or candidate 2, just increment the frequencies. You in this iteration you just need to count the frequencies. So is it equal to candidate 1, candidate 2? No. Is it equal to candidate 1 or candidate 2? No. Is it equal to candidate 1? Yes. Increment the frequency. This is equal to candidate 1. Increment the frequency. Candidate 1, increment the frequency. Candidate 1, increment the frequency. So these all values are equal to candidate second, increment the frequency. So for the candidate 1, the frequency is 4. For the candidate 6, the frequency is 5. So you just need to check, is it equal to n by 3? Is it greater than n by 3? In this case, n is 1, 2, 3, 4, 5, 6. 6 and 5 is equal to 11. 11 by 3 is equal to 3. Is it greater than 3? Yes. Is it greater than 3? Yes. So the answer is 5 and 6. So this is the crucial point. Many users will face the same error that I was facing before. In the problem description, it is not given. Either we have to return in an increasing order or return in an decreasing order, or we have to just look for the values, and whichever value comes before, we need to consider that value. It is not mentioned in the problem description at all. So you need to follow the same set of instructions that I followed. So after that only you will have the successfully submission. So that's about this. In this case, the answers, the candidates are 2. So we have this test case also. So let's solve for this test case. A value is maximum, candidate 1 is 0. B value is maximum, candidate 2 is 0. Candidate 2 means frequency. First we have value 1. Is it equal to this? No. and it is not pointing to any value. So just point to this value, frequency is 1. Next value is 1, frequency is 2, frequency is 3. Next we have 5. 5, is it equal to this? No. Is it equal to this? No. The second candidate is not pointing to any value at all. So just initialize candidate to 5 and increment the frequency. Is it equal to this? No. Is it equal to this? No. So neither this value is equal to this or equal to this. So on this step, just decrement the frequencies of both values. So after that we have candidate this and candidate this. So you just need to iterate and count the frequency. For 1, the frequencies are 3. For value 5, the frequency is 1. And you need to check for n by 3. In this case, n is 5, n by 3 is 1. So is this frequency is greater than 1? Yes. So we have one answer. Is it frequency greater than 1? No. So we have only one answer. So that's about this. So let's suppose you have 5 and 3. Let's suppose you have 5 and 3. In this case, your value is equal to 5 and C1 is equal to 1. Second value is equal to 3 and C2 is equal to 1. And 2 by 2 is greater than 1. So greater than 1. Is it greater than 1? No. Is it greater than 1? No. So in that case, you just need to return -1 as a array list. So that's about the approach. Let's code this. So we have maximum and our A and B initially pointing to maximum. Next we have candidate 1, candidate 2. So this is the frequency of candidate 1, frequency of candidate 2. Next, a simple for loop. If the value is equal to the current value, if the candidate 1 is equal to the current value, increment the frequency. Else if the current value is equal to candidate B, so just increment the frequency to. Else if we have frequency 1 as 0, so this is the new value. So assign this new value to candidate 1 and assign 1 to frequency 1. If our second candidate frequency is 0, so this is the new value for second candidate. So just assign this current value to the second candidate and reinitialize the frequency to. If the new value is neither equal to candidate 1, neither equal to candidate 2, so on this step, just decrement the frequency 1 and frequency 2. So after you are done with this for loop, you have candidate 1 and candidate 2, value A and value B. So on the next iteration, you just need to count the frequency of candidate 1 and candidate 2. On other words, value A and value B, and store it in an answer list. So we have a loop. If the current value is equal to A, increment frequency 1. As if it is equal to candidate 2, increment frequency 2. If our frequency 1 is greater than n by 3, it means our candidate 1 frequency is greater than n by 3. So we need to consider A. Same applies for B. If the size is 0, so return -1. If the size is not 0, return the answer. So this is the steps. So you need to follow the same set of instructions. After that only you will have the successfully submission. So let's give it a try. And let's talk about time and space complexity. So it is pretty clear. The time complexity is order of n and space complexity is constant. The code is given in the description box. If you guys have any doubt related to this question, feel free to comment down below. And if you like this video, give it a thumbs up, subscribe to this channel, and thank you all for watching.